In this video, we'll be looking at the concept of constant rate of change in general. In one of the previous videos, you looked at constant speed. For speed, the two attributes of the car's motion we focused on were change in time and change in distance. Constant speed meant that for any fixed amount of change in time, the corresponding change in distance is constant. So in the example, for each 2-minute interval, there was a corresponding 59-meter change in distance. This also meant that once we fixed any interval of time, 1-second intervals, half-second intervals, etc., each interval had the same amount of change in distance. In another previous video, we looked at a constant rate of fuel consumption. For fuel economy, the two attributes of the truck's trip we focused on were change in amount of fuel and change in distance. Constant fuel economy meant for any fixed amount of change in gallons, the amount of change in distance is constant. So in the example, for each 1/10 of a gallon of fuel consumed, there was a corresponding 3.4-mile change in distance. This also meant that once we fixed any interval of change in fuel, 1/10 of a gallon intervals, 1/20th of a gallon intervals, etc., each interval had the same amount of change in distance. So in general, whenever you are thinking about a scenario, you first need to identify two measurable attributes, two things you can measure. It could be time and distance, or amount of fuel and distance, or any other pair of measurable attributes. And in general, we can focus on any pair of measurable attributes. We'll call these attributes x and y. And we'll make sure that we're using the appropriate units, x units and y units. Then you need to focus on the amount of change for the x variable. For example, 2-minute intervals, 1/10 of a gallon intervals, and so on. Here we'll call the amount of change in x delta x. Finally, you need to coordinate the amounts of change for the two types of intervals. Here, we want to see, for any fixed amount of change in x, what is the amount of change in y? In this case, the amount of change in y is the same for each interval. So, for any fixed amount of change in x, the corresponding change in y is constant. And this also means that there is a specific multiplicative relationship between these amounts of change. For example, with constant speed, we saw that the change in distance in meters is always 59/2 as large as the change in time in seconds. And with constant fuel economy, we saw that the change in distance in meters was always 34 times as large as the change in the amount of fuel in gallons. So in general, a constant rate of change of y with respect to x means that the change in y units is delta y over delta x times as large as the change in x units.